Okay, that concludes chapter 1. In chapter 1, we talk about the requirements and also the principles. So you can see the requirement on connectivity, scalability, and resource sharing. They are the objective that we want to achieve. But when we want to reach the objective, we have some constraint, the principle to follow. Okay. Then we come out some solution, and TCP/IP or the internet is the dominant solution. It's not the only solution, but the dominant solution. There are some other solutions. We have compared the internet solution with the other solutions. So we know the philosophy within the internet. And there are key concepts, and then a solution, and then for each solution there could be many implementations. Say for TCP/IP, there are many implementations, and Linux is just one of the implementation, and it's open source. There's another implementation which is also open source, BSD, but BSD and Linux, they have different license model, and it turns out that Linux become dominant because it allows faster, more open development model than BSD. BSD has a more closed development model that only limited people can contribute. However, Linux give a more open model that many people could contribute. And we also cover some key concepts for switching, routing. So we talk about why switching is faster than routing, but switching is stable. You need to keep something, keep the state. A state is usually mean a table entry, that you memorize how to switch a packet within a connection. So it's stable. However, routing is stateless. So we talk about the concept here, and we also talk about the stateless and soft state, hard state. And we talk about best effort, which is IP, meaning you will try its best, but no guarantee. And we talk about the concept of data plane and control plane. And we talk about the philosophy behind the internet architecture. And two biggest design decisions are the end-to-end argument. It says that you don't want to put it in the middle layer unless it can be totally resolved there. So that philosophy or that argument will push the complexity to the end-to-end and keeping the lower layer simple. Okay, and in turn that will push the complexity to the end host while keeping the core network simple. So then you will have a stateless core, which is stateless core or stateless IP layer. It means the same thing. Stateless core network or stateless IP layer. And then best effort IP. However, some application does need the reliability, and that could be offered by additional transport layer, which is TCP. However, some applications don't need the reliability or cannot accept that kind of reliability overhead. Then they would use UDP, which is a primitive transport protocol. Okay. Another design decision will be the three-level hierarchy. Okay, with the architecture of subnet and domain, and that give us a good scalability, enough to scale to billions of hosts. Okay, the final remark for this chapter will be the evolving glass of the protocol stack. So the protocol stack actually look like an hourglass, where you have the IP layer, the single IP technology in the middle, and many link technology at the bottom, and a huge number of applications at the top. So it's a evolving hourglass. How is it? Where is it evolving to? Well, in the middle, the IP layer is evolving from IPv4 to IPv6, and we will see that in chapter 4. When we talk about IP layer, we also talk about IPv6 and how it differs from v4 and why. And how about the link layer? Most of there's most of the development in the link layer or the physical layer are the wireless, well, and optical. Some are optical, but mostly on wireless links. So you will see in chapter 2, we would have quite advanced modulation schemes that handle the noisy wireless channels. So the wireless channel is quite noisy and vulnerable, so you need quite sophisticated schemes in the physical layer and also the link layer, so that you could pump more bit rate. So the link layer, some development on the optical technology, optical links, but majority will be on wireless. How about the application? Where are we evolving to? In application, people are talking about, well, right now, we have the well-known client-server protocols, and that are quite mature, the client-server protocol. And now we are developing a lot of peer-to-peer protocols. And unfortunately, those peer-to-peer protocols are mostly proprietary protocols, not standardized for those peer-to-peer. And for those peer-to-peer, meaning that from the client-server application paradigm shift to peer-to-peer application paradigm, what has been changed? In the client-server model, usually the client are the information consumer, while the servers are information providers. But in the peer-to-peer model, everyone will be information provider and also information consumer at the same time. So you see the idea of Web 2.0. So the idea of Web 2.0 is that everyone could be information provider, not just the server. In the traditional client-server model, everyone, well, the client is nothing. Only the servers are visible. But in the Web 2.0, everyone could be visible because of this architecture. So you see some social network, for example, the Facebook, Twitter, that enable the client to become visible, not just the server. Everyone could be visible and providing information to others. So a lot of interesting development in the application layer, and also another interesting thing is the machine-to-machine application. Machine-to-application. Well, perhaps in next decade, the device will talk to each other, and that's another form of peer-to-peer. But the peer is not human; it's a machine. So then you will see some machine-to-machine applications. Okay, that concludes chapter 1. I hope you have finished. You have finished or almost finished reading chapter 1, and the first homework due next week in the class. And at the end of the chapter, there's an FAQ, so you can look at the FAQ to see whether you understand the question and also the answer. The answers are there in the FAQ, and also there's a common pitfall that might correct some of your confusions. So read the common pitfalls, and then further readings tell you about some other books or papers. Okay, and then exercise, the hands-on and written exercise.